I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, November 3rd. Tonight we'll be discussing significant wave heights, jet stream level winds, surface level pressure, and all the things that go into making waves in the North Pacific Ocean. We'll also take a quick look at precipitation potential for the U.S. West Coast. Let's get to work. Taking a look at significant wave heights for the North Pacific Ocean, we see a gale north of Hawaii, generating 21-foot seas aimed south at the Hawaiian Islands, not so much at the U.S. West Coast, and then a tropical system generating seas in the far West Pacific Ocean. So let's start off looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they do form, help to direct their track. We're looking for a trough, and we see a pretty clear one right here. That is a dip in the jet stream to the south. Its apex is just, what is that, about 600 miles north of Hawaii. That flow helps create a counterclockwise circulation aloft and down at the surface, and that's the hallmark of low pressure in the northern hemisphere. Of course, low pressure generates wind, winds generate seas. Seas, as they radiate away from the fetch area, eventually turn into swell. Swell, when it hits your beach, turns into surf. So we have a little bit of hope here, and as we saw from the significant wave height charts, we know that something has developed here and is producing some seas pushing at least towards Hawaii. So let's put this into motion, take a look, and see what happens. We also see that trough continues into Monday. Wind's still pretty decent, pushing off Japan. Was at about 150 knots, but getting very weak. The jet almost splitting. You almost see a northern branch there and a southern branch there. Then they come together real quickly here north of Hawaii. Then it splits kind of again with part of the flow pushing into Baja, but the main energy ridging, that is, pushing hard to the north, up into Alaska and into the interior U.S. West Coast. That ridging pattern creates a clockwise flow, and that, in turn, is the hallmark of high pressure. And we know that high pressure is locked down off the U.S. West Coast. Nary a cloud to be seen in the sky, and light offshore winds. That's what's been going on for almost a week now, if not more. All right, we move this into motion. Taking a look into Monday night, the trough starts looking to fall apart. Still sort of there, but you see the jet starting to really split here once it hits the dateline. Part pushing up into the Bering Sea, the other part falling into what's left of the trough, but it's very pinched, offering no support for gale development. That continues, but then interestingly, as we get about into Wednesday, notice the northern branch, the part that split off here, is all but gone. We get sort of this singular flow appearing to try to push across the Pacific and towards the U.S. West Coast, the ridge significantly fading, if that is to be believed. As we get into Thursday and Friday, you get this sense again, and the jet starts building some wind energy, tries to split, but then it looks like another trough might be starting to set up north of Hawaii as we get into Friday. And look at that, wind energy finally building. What's that, to 170 knots or so? Maybe even more, 190 knots next Saturday, and a somewhat decent trough trying to organize in the Gulf, and they're even getting a little bit better organized with 200 knot winds. But notice, the winds fall south, and then there's like a complete break, and then they ridge hard north. You really need those winds to fall down, wrap through the bottom of the trough, and up into the ridge on the other side of it to get a good counterclockwise flow going here. But the plus side is the ridge here, instead of being way up into Alaska, is now just like off Cape Mendocino as of Sunday, and we'll just roll this out the whole way. Builds a little bit further north as we get into Monday, but still much suppressed compared to what it is as of right now. In fact, we can just go, boom, there you go. Look at that ridge. That's where we're going to be a week from now. That's a harbinger that maybe fall is trying to get a little bit better organized. All right, let's go take a look at surface level pressure. Here we are, surface level pressure, surface level winds. We see currently the gale, or what's left of the gale, north of Hawaii, barely 35 knot winds is what you need for a gale. Little tiny, that little brown there, see, 35, 40 knots, right there, not much. Mainly 25 knot winds, barely 30 knot winds. That's wind swell. We're talking 11, 12-second period swell. But regardless, it's something. And then here's our tropical system off in the West Pacific. We'll put this into motion. We see our trough and our low pressure system here pushing a little bit of fetch. Let's go back. Tiny little bit of fetch at the U.S. West Coast. That's good for, maybe waist-high waves or something for a day or two when it eventually develops. Here comes low pressure system trying to organize off Kamchatka on Monday night. All energy going up into the Bering Sea. Nothing expected from that. Tropical system starts making the turn here to the north. You see low pressure building. You go, hey, this actually looks like it's going to be something, maybe. And then notice this high pressure system here. And watch the tropical system just get sheared off and nothing really comes of it. Unfortunately, that's too bad because earlier runs of the model had it being extremely strong, pushing over the date line. That was 2 days ago. As of, I think it was last night sometime, it just disappeared from the charts, and that still appears to be the case as of right now. So we're into Saturday of next week. Weak low pressure in the Gulf. No fetch of interest. Another tropical system supposedly in the far West Pacific. We continue on into Sunday, Monday. Supposedly this other tropical system is going to recurve. We don't buy any of that. Oops. And there we are, 180 hours out. High pressure has weakened off the U.S. West Coast, but still just a pretty diffuse, not well organized wind pattern over the North Pacific Ocean, unfortunately. So let's go take a look at significant wave heights, and we're back to Saturday, just 24 hours ago. This little gale that formed north of Hawaii produced a small area of 27-foot seas. It's max seas over this whole frame here, and they're at 38 north, 168.5 west, so right there. So certainly in the Hawaiian swell window for exposed northwest-facing breaks, and it fell south, producing 29-foot seas about midday Saturday, down to 27-foot seas, and you get the picture. It kind of faded out. Here we are at 18 seas Sunday, 21-foot seas, but certainly the northward motion, the southward motion here. Check this out. Put this in motion. Just watch it fall south. Whichever direction the seas are falling, that's the way the swell is going to mainly project, so down this way. And then let's go take a quick look at the forecast. So here we are, and then you see just a tiny little bit of seas, 20-foot seas on Sunday night into early Monday, pushing off to the east before the whole system basically collapses and just dies. If you don't have at least 20, 21-foot seas, you're not going to get any swell radiating any significant distance because it doesn't have enough energy. When you're down in the wind swell period, yeah, it can go 800 miles or 1,000 miles or something like that, but the swell significantly decays as it radiates away from the fetch area, and there's not much left by the time it'll reach the U.S. West Coast. Hawaii, though, of course, will get swell. All right, moving on. We're not expecting to see anything here. Here's our tropical system. It just vaporizes, no seas of interest. The other tropical system supposedly meandering somewhere way off in the West Pacific. On Saturday night, little bit of fetch up here in the Gulf. Still, nothing. Just nothing. 20-foot seas over that small of an area, you're not going to get any meaningful swell from that. Now look at this. Supposedly at 180 hours out, yes, you're getting something here south of Japan, supposedly starting to turn towards the U.S. West Coast, but like the previous tropical system, we believe this will probably vaporize too. So we're not holding our breath there at all. Now, interesting, a little small cutoff low developed in the southern hemisphere today, and put this, there we go, pull that away, there you go. See a little area of 30-foot seas right there, starting to develop as of, this is forecast as for Sunday, 10 o'clock at night, pushing north. Now, Tahiti and all associated islands are sitting right there, going to be fully blocking California, but that's not to say there won't be swell. And swell, so Hawaii's at like 158 west, completely unshadowed, so some swell could radiate there as well. And then you see this system fading out. I'll pull this away as we get into Monday night. And that's pretty much it. This other system well east of even the Southern California swell window. And that's it for the southern hemi. I mean, we'll roll this out for the whole week just so you can see what, oh, they're actually, this is new. What is that, 20, 22, 25, 25-foot seas? Yeah, maybe some 14-second period swell could result up into Southern California with luck, but it'd be pretty small if it does, and we're pretty late in the season. That's it other than that, but some small swell from that initial gale that we just saw. So then we get into the desperation search, wind swell, any potential for wind swell. So here we are Sunday, little tiny fetch of 20-knot winds off of Cape Mendocino relative to North and Central California. That probably is not going to generate any swell. And there's no real east swell east of Hawaii to produce any meaningful wind swell. We get into Monday, pretty much the same thing. A little bit of building fetch here, well east of Hawaii. A little bit larger fetch off of California, but no real wind swell expected. We get into Wednesday. Pretty much the same thing. You got a broader area, 20-knot winds. Okay, we'll say some 7 or 8-second period wind swell probably for Northern California down to exposed breaks down to maybe Monterey or something like that. No real east fetch east of Hawaii until we get into Thursday. I mean, you see the trades down here trying to blow up, but most of them are south of the Big Island. Yeah, you can get wind swell on the east side of the Big Island, but up relative to Oahu, Maui, Kauai. Not likely any hope there. Oh, let's go back and just take a look. And you watch this fetch out here relative to California. No, nothing from that either. We're into Friday. No winds off of California. No fetch east of Hawaii. I mean, it's real late in the year for wind swell anyway. Here's that little low we saw up in the Gulf as we get into Saturday. It actually looks better here. A little bit of fetch off of Northern California. But again, what are we talking about? That is 25-knot winds. Yeah, okay. We'll say a little wind swell maybe on Sunday. If you believe the model's that far out, and we're out 180 hours, and that's it. So, of course, given this time of year, you wouldn't expect... This is actually kind of a typical pattern. High pressure in control, but losing energy as you get deeper into fall. The wind swell fades out. Fall or winter hasn't really kicked up. No strong winter lows blowing in. So you get no ground swell, no wind swell. The southern hemi's asleep, and everything just kind of gets very quiet. Now, typically this time of year, we would have had at least a couple of decent North Pacific gales producing swell relative to California, but so far everything's been sort of falling on this north-south axis towards Hawaii because the high pressure here is blocking everything. So the storms form, then they quickly get shunted off to the north. California locked out of the equation. Hawaii getting all the energy as of right now. And then precipitation potential. Well, you can see here, high pressure, 1026 millibars, just circulating this way, just making a wall. You can see precipitation out here north of Hawaii associated with the low there, all getting shunted off to the north and then streaming inland. The high also ridging into almost the Four Corners region. The precipitation track is north of of Vancouver area, Whistler, that area, well inland. Not unusual for this time of the year. We'll just put this into motion. We're really looking at precipitation here relative to California, and we don't expect we're going to see anything, but we'll go through the motions here just the same, and we're not seeing anything. Same sort of pattern. There we are, 180 hours out. So there are some models that go out weeks and months. We looked at those, and they suggest that somewhere around mid-November, this high, you can see it is breaking down, and it's going to continue to erode and supposedly allow some little bits of moisture into the state, before Thanksgiving. Nothing of any real volume, but maybe something to try to push us into the fall season. But we don't believe a model 3 or 4 days out, much less 2 or 3 weeks. So take that all with a grain of salt. So let's go take a look real long term. MJO, we're talking out 2, 3, 4 weeks. Then beyond that, El Nino, La Nina, or who knows what. Let's dig into that. So we'd like to first look at the MJO. And how do we do that? We look at winds over the equatorial Pacific. This is the equator here. This is the East Pacific. This is the West Pacific. The arrows are actual wind speeds as indicated by the TAO buoy array, series of buoys strung across the equator, used primarily for monitoring El Nino. These are 5-day average winds, but still, if you watch closely, you can get a sense of what's going on with the MJO. And the MJO has two states, an active state and an inactive state. When the MJO takes about 3 to 4 weeks to traverse the Pacific. It goes from west to east, and it's either normally in either the active state going over the Pacific or the inactive state. Okay, so we're looking for signs of that. When in the active state, the MJO tends to feed energy, it creates clouds, feeds energy to the jet stream, which in turn helps support storm formation. We have been in the inactive state of the MJO, a pretty strong one for a couple of weeks now, so that explains the relative lack of storm production and surf. The question is, are we getting ready to turn the corner? All right, so east winds, pretty strong over the eastern part of the Pacific, over the central Pacific, and hard out of the east on the date line. That does not bode well. That looks like the inactive phase of the MJO. And then you get to 170 east, and all of a sudden, the winds just die. And if anything, there's one little indicator here of maybe westerly winds starting to develop. But it's not the actual winds, it's the anomalies. Differences from normal for this time of year. Looking down here at the anomaly portion of the chart, we see, hey, these winds are pretty normal. Normal easterly trades, a little bit stronger than normal on the date line, but then almost weakly out of the west in what we call the Kelvin wave generation area, basically the far west Pacific, but especially we're interested in the area from 5 north to 5 south, from 135 east over to 170 west. When you get good west anomalies in here, that can help create Kelvin waves, which are balls of warm water that can be driven by strong west winds here. Normally you see that warm water right there. You can have warm water here. Westerly anomalies push it to depth, and then that pool of warm water travels under the equator, erupts off of Ecuador, the Galapagos, forms a warm pool, and if you get successive Kelvin waves, that can be the start of El Nino. Looking at the forecast, this is zonal wind anomalies, and it just looks like a fancy colored chart, but if you know what you're looking at, so this is the whole planet on one chart. We're looking for yellows and reds because those are westerly anomalies. The blues are easterly anomalies. Yellows and reds, westerly anomalies, are associated with the active phase of the MJO, and so that's what we're looking for. So right now, here's the current date, November 3rd. The Pacific runs from about 130 east, so a line going right up here, the whole way to about 90 or 80 west, so right over here. Kelvin wave generation area, though, from 135 east to 170 west, so between about here and here, going the whole way up the chart. You see, hey, developing westerly anomalies in the far west Kelvin wave generation area starting about 2 days ago. But then you have these strong easterly anomalies in the other half of the Kelvin wave generation area, and that pattern is supposed to hold for the next, well, that's 5 days. And then 7 days out, the westerly anomalies start fading, maybe building east a little, but also the easterly anomalies fade out. So the thought is, you can look at this chart and you pretty much go, see the blue here moving off to the east? This is probably the inactive phase of the MJO right here. This was up here, this was the fading previous active phase in like early October, and then in mid-October, inactive phase took over. It's trying to work its way across the Pacific and out of the picture, and the active phase here in early November trying to work itself into the picture. All right, let's dig a little deeper. So here's another MJO forecast chart. This is looking at the outgoing long wave radiation, fancy way of saying rainfall or cloud cover, associated with the active phase of the MJO. So differences in normal for this time of year in terms of precipitation. And so today we see blues. Blues are negative anomalies. Negative anomalies mean less outgoing long wave radiation, less sunlight reflectivity off the ocean surface. Fancy way of saying, hey, there's a lot more clouds here than normal, which means the active phase of the MJO, and that's exactly what we want to see. So active phase today, forecast to continue 5 days out, fading a little 10 days out, and then gone 15 days out. That per the statistic model. The dynamic model shows exactly the same pattern. So both models in agreement, suggesting some sort of active phase of the MJO per probably pretty much for the next 2 weeks at least. So that's some good news. But we never believe just one model, so we want to look at multiple dimensions of this MJO scenario. So this chart, what is this? They're called phase diagram charts. It's a way of looking at the strength and position of the core of the active phase of the MJO. So this circle, assuming this is the North Pole and you're looking down on the North Pole, the equator is out around here somewhere. The MJO moves west-east from the Indian Ocean over the Maritime Continent, over the West Pacific, under the United States, across the Atlantic, across North Africa, back to the Indian Ocean. Where the heavy dot is where the active phase is. So it's in the Maritime Continent, like Bali, maybe a little bit east of Bali. And then these three colors are three different forecast members of where the MJO is supposed to be over the next 2 weeks. And the further these lines are away from this circle, the stronger the MJO, the active phase, is supposed to be. So, according to the statistic model, active phase making it into the West Pacific, getting progressively weaker. The dynamic model here, same deal, but suggesting the active phase getting a little bit stronger, making it a little bit further into the West Pacific for maybe about a week before it starts collapsing in the, we'll say, the Central Pacific. So far, good agreement between the models. And then the upper level model. This is up jet stream level. So multiple panels here. I think they're 5 days each in length. This is a 40-day run of the model. South America there, the equator right there, New Guinea there, date lines right about there. Australia, you get the picture. The greens suggest areas favorable for precipitation, meaning the active phase, the MJO. Pretty strong too. Active phase supposed to make its way across into the Central Pacific through about mid-November. November, what's that, 18th? And then weakening as it pushes into Central America. A strong inactive phase develops about the same time, let's say about mid-November, pushing its way across the Pacific into the 13th of December. At that point in time, yet another active phase, we'll call it a medium strength active phase, starts developing in the far West Pacific. Notice these each of these phases are far stronger than anything we've seen for a while now. Do we believe it? Hard to say, because sometimes this chart suggests strong active phase and then it really doesn't materialize nearly as strong as one would think, but something to keep in mind. Here's a 1 month MJO model. It's really upper level winds, a bunch of stuff, surface level, 850 millibar zonal wind anomalies. So that's at 4,700 feet. All right, so what are we looking at? Again, whole planet on one chart. Kelvin wave generation area from here to here going up. Okay, here's where we are today, November 2nd. This is the forecast going down, past performance going up. This over here, this dark blue, it looks very scary, strong easterly anomalies. It's all in the Indian Ocean, so never to fear. So we see the dotted line here. That is the inactive phase of the MJO. It's past and moving its way, should be out of even south of California by about a week from now. Active phase starting to develop in the West Pacific, westerly anomalies, that's what the orange and reds are. A area favorable here, or a window favorable for storm production starting today, going through, say, pretty much the whole rest of the month till Thanksgiving. Then we see the dotted contour, another inactive phase, starting to push into the far West Pacific at that time, but then the chart runs out. So that means we need to go to a longer term chart. And then here is the long term, the 3-month CFS model. Now this is a little different. Past performance is down here. The forecast is to the top, but the Kelvin wave generation area still in the same place from about here to here, going straight up the chart. The good news is, here's where we are today. Here's our westerly anomalies developing in the western Kelvin wave generation area. Here's our easterly anomalies on the date line. That situation is supposed to last about 5 days. And then look at this. Westerly anomalies take over the Kelvin wave generation area from, we'll say, November 11th the whole way through till pretty much the end of December. If one can believe that, that's pretty good. Let's overlay the MJO. Here we go, and we can see why. All right, so the dotted contours are the inactive phase of the MJO, and we're going up. That is pushing east. California is about 120 west, so it's it'll be out of the picture here in a week or so. active MJO and control feeding westerly anomalies. It kind of fades, then redevelops before it pushes out of the California swell window right around Christmas time or so. After that, inactive phase sets up. Westerly anomalies are forecast to die into early January. And then as we get into the new year, yeah, an active phase sets up, but westerly anomalies fading out. Also notice these easterly anomalies here at, what is that, like 70 or 80 east? That's in the Indian Ocean. Their easternmost periphery is, we'll say, 120 east. And then, but as we get up here into like the new year, you get the sense that easterly anomalies are going to start moving into the Kelvin wave generation area. Maybe somewhat suggestive of La Nina, but maybe not. It's hard to tell. Let's overlay the low-pass filter. Now there you go. Now here's a completely different story. The dark line, the low-pass filter, when it's the solid contour, suggests a low-pressure bias. And it's in the Kelvin wave generation area and has been for months now. It recently built to 2 contour lines, suggesting the low-pressure bias is getting stronger. And now it's forecast to build to 3 contour lines, but just for, what is that, maybe 2 weeks or something like that at the end of the year, and then starting to fade. The high-pressure bias here, no surprise, that's where all the cold water is. Cold water does not support evaporation. Evaporation is a sure sign of low pressure. So stable, high pressure in the Indian Ocean. Forecast to stay there for at least through the end of January. So no clear signs of La Nina according to this yet. All right, so enough of the MJO. Let's start looking at the El Nino La Nina setup. And specifically what we're looking at is the ocean subsurface temperatures. We're looking for Kelvin waves. We're looking for any signs that maybe El Nino or La Nina are trying to develop. Okay, so what do we have here? This is the West Pacific Ocean. This is the East Pacific Ocean. This is water temperatures in centigrade. The X's, these are the anchor lines on the TAO buoys. Those buoys strung across the equator. And the X's are the actual sensors on the buoy lines. So they report data via satellite up to some central reporting location that aggregates all the data. And then they use a model to fill in the gaps. And what do we see? Well, warm water in the west, cooler water in the east. We see these temperature lines, the 31, so this is 31 degrees Celsius. That's new. That's actually warmer than what it's been. The 30-degree line at about 177 east. That's about where it's been. The 29-degree isotherm line, 170. I think that it might have been over to 167 last week. The 28-degree isotherm line, I think it was at 157 last week. It's given up maybe 2 degrees, which isn't much. Then the 24-degree isotherm, pretty much steady. I think it was 105 last week. It's dropped back 2 degrees. 2 degrees latitude, that is, not 2 degrees in temperature. So basically, still a reasonably warm pattern trying to push its way into the East Pacific. Now we're looking for Kelvin waves, that is, warm water moving off to the east. So one way you can do is you sort of monitor where these lines are and if they're inching off to the east, but the far easier way is just go look at this chart, the second half of the chart. Anomalies, differences in temperature as compared to normal for this time of year. And what we see is 1 and 2 degrees Celsius, and a degree Celsius is, I think it was at 1.8 degrees Fahrenheit, so what is that? 3.5 degrees above normal here. So we see warm water seeping out from the maritime continent into the far West Pacific, creating a ball of warm water there that almost looks like a Kelvin wave. And then another wave, for sure, this is Kelvin wave number 5. I think this was generated back in late August, September, sort of, or no, even before then, August I think it was, from a westerly wind burst in an active phase of the MJO that occurred then. It is working its way towards Ecuador. Temperatures now up to 3 degrees. It was 2 degrees last week. And the more important part is there was cool water that was all down here. It's starting to almost look like it was going to undercut everything. It is significantly backed off, retreated, looking weaker than it ever did before. This is good news. Now, this is no sign of El Nino, but it's suggestive of just a weak, normal, meandering, warm, occasional Kelvin waves, but nothing strong, nothing, smelling of El Nino, but certainly nothing smelling of La Nina either. So here's a different model of the same sort of data, using the same data, and it's painting very much the same picture. Warm water, what is this? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 4 degrees above normal centigrade in this one little spot here, but generally 2 to 3 degrees above normal. Certainly a Kelvin wave pushing off to the east, last little bit of cool water here, making it maybe to the Galapagos or so. Ecuador, I think, is at about 80 west, so won't be long. This guy's moving off to the east. He's going to squeeze all that cold water out at the surface, and then probably a 3-month warm regime to follow. Now the point goes, hey, that's great news. We're going to have warm water in the East Pacific. Of course, warm water helps support evaporation. Evaporation helps feed energy in the jet stream. Will that do anything for the atmosphere? Well, let's be clear here. The atmosphere, it takes more than 1 Kelvin wave to get the atmosphere to change its configuration, especially the upper level jet stream. You need multiple Kelvin waves over multiple, like 6 to 9 months. This whole event here is probably a 3-month event, and the atmosphere won't budge an inch. So likely, whatever's going on now, whatever bias or rut that the atmosphere is in now, it's probably going to stay that way for the next 3 to 4 months. So, but still, this is better than just steady cold water, because then that would be La Nina. If anything, this just looks like we'll say neutral, biased weakly towards El Nino, but not really. From a purely numeric standpoint, just ENSO neutral. Sea level anomalies. Okay, so this is another way to measure subsurface temperature depth, but rather indirectly. Satellite data used to measure the height of the ocean. That is, you strip out the waves, you strip out the wind waves, you strip out the tides, and just is the ocean surface higher or lower than normal? And only right here on the equator. There's 10 north, 10 south. It's 5 degrees north and south. It'll just draw a swath right through there. And all we see is right here, this one little pocket of positive 0 to 5 centimeter anomalies. So warm water depth expands. That creates a bump on the ocean surface. That's what's going on here. So this is saying, and now it's interesting because last week we had a lot of warm water here, and we're not sure what's going on. Could be, just the satellite is having problems interpreting what's going on. We still think there's a pretty fair amount of warm water right here, and certainly here, but the satellite's not picking it all up. But the good news is, it's not showing any building cool pool or anything off here, which would be what we'd be more concerned with if we're looking for La Nina. And yet one more subsurface chart. This is upper ocean heat anomalies, the upper 300 meters of the ocean surface. That's all we care about. So what this does is, so this is the West Pacific here, East Pacific here. We've been through this drill before. Basically gives you a historical perspective of what is going on Kelvin-wise over the past year. So here we are, like November last year. Warm water, the oranges, reds, pushing from west to east into Ecuador. That was Kelvin wave number 3. Kelvin wave number 4 was in January. You could see it making its trek across the Pacific, all driven by west. So you get westerly anomalies like in the January time frame from the active phase of the MJO blowing hard for, let's say, 2 to 3 weeks. And then they take warm water that's here, start pushing it east. And then, so this was, let's say, early January. And then in April, that warm water finally makes it to Ecuador and erupts on the ocean surface. Okay, so then we had 2 like baby Kelvin waves, very weak. They sort of made it to the central Pacific and just died there. They didn't go anywhere. And now finally, we had a little bit stronger westerly wind burst back in, what did we say, the August time frame, and it created yet this other weak Kelvin wave. This is the one that's currently easing its way across. It's at, according to this, leading edge is at about 95 west. Ecuador is right there. So imminent arrival in, let's say, the next 3 weeks on the Ecuadorian coast, but no big result is expected from it. So let's go talk sea surface temperatures just for a second. So the main site that we use for getting the high-res sea surface temperature data, they're having some sort of server errors, but we can get to the data otherwise. So Of interest, the sea surface temperature trend for the past 7 days. What's been going on? Well, we have warming here off of Ecuador. There's the Galapagos, and pretty much warming out to about 120 west. Not strong warming. It's only on the equator that we're interested in. And light warming off of Peru. That's kind of new and kind of favorable. So just maybe the last little bit of the cold water that's sitting under here at depth is being squeezed to the surface and pretty much out of the picture. Hard to say, but otherwise, no large-scale warming pattern, but no large-scale cooling pattern occurring either in the equatorial Pacific. The actual sea surface temperature anomalies, differences from normal for this time of year. All right, well, if we were in El Nino, you'd see baking hot temperatures right in here from off of northern Chile out to about 160 west and up into Mexico. We don't see that. We see mild warming here off of Mexico. A little bit of warming on the equator here, and then weirdly it's kind of like split. Warm in the northern half, a little bit cooler in the southern half. The official El Nino monitoring region is 5 degrees north and south, right, starting at 120 west out to 170, so right in here. But we like to see what's going on here. It gives you sort of a sense of what's going on. And wherever the water is warm, you know, if this whole area, especially down south, were warm south of California, that would be a harbinger of maybe a good precipitation season for California. But you got this weekly warm, weekly cool pattern south of the state, suggesting, well, things are pretty much just sort of normal. And so one would think, okay, we'll get normal rainfall for California, but it seems like even that's going to be a hard bet to have happen this year, the way things are going. Here's the sea surface temperature index for the Nino 1.2 region. This is the area right there along the Galapagos, Ecuador, off of Peru. Temperatures today, 0.727 below normal, so 3/4 of a degree below normal, and you can see since August at least, they've been pretty much below normal. The trend is not going any lower, but certainly not coming up. If I drew a trend through here, it's about a degree below normal. Then for the Nino 3.4 region, the official El Nino monitoring region, there we go. The good news is the trend's actually upward. We're not as cold as we were back in August and early September, but we're still not really warm. We're at 0.233, 0.2 of a degree above normal. For El Nino, you got to be at least half a degree above normal for, I think it's 5 consecutive months. We're nowhere close to that, but we're not down in the negative territory, so we're not El Nino, we're not La Nina, we're just somewhere in the normal category. So what's going on in the atmosphere above the ocean? Yet one more component of El Nino or La Nina. All right, so the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. When the index is negative, and negative for a, 10 or 12 days, something like that, maybe that's a sign of the coming active phase of the MJO. That means lower pressure is over Tahiti than over Darwin. When the index is positive, it then suggests the inactive phase of the MJO. All right, so the daily contribution, minus 10.31, that's good. Just sort of looking back, the numbers have been generally negative for, I think it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 days. Okay, so maybe we're moving towards a weak active phase of the MJO. 30-day average, that's a way to sort of tease out the phases of the MJO. We were at minus 2.56 or something like that. We're down to minus 4.05. So, yeah, weekly moving towards the active phase. The 90-day average, that's your El Nino La Nina indicator. It's negative too, but it needs to be down at like minus 15 for you to have El Nino. We're at minus 6.62. And if it's this time of year, El Nino peaks in like, Christmas time frame. This guy would have to be down at minus 15 right now. We're nowhere close to that. Looking at the trend, we'll just sort of go back here. Well, it was at minus 7.96 in early October. We're not a whole lot different from that. So basically, the ENSO index is going nowhere. We're just kind of floundering. All the data suggests we're not going to La Nina. We're certainly not going to El Nino. We're just in this dead zone in between the two, which one could infer as being neutral, but it seems like the jet stream in the atmosphere do best in terms of storm production when you have a push one way or the other. Even a push towards La Nina can give you bursts of strong storms for a short period of time. The preference, though, is the push towards El Nino. That way you get longer sustained storms of longer duration, bigger swells, all that kind of stuff. And here's the 30-day Southern Oscillation Index graphed out for the past, 2 years or so, something like that. You get a sense of what's been going on. So here is your La Nina component up here, which 2018 was kind of looking that way. And then we got into late 2018, the index started falling if you drew a trend line through there. But now, since pretty much this whole year, we've just been hovering somewhere between -5 and -15. We'll say -8, something like that. And no real change indicated. So you can actually see these downward pushes are the active phase of the MJO. These are the inactive phase. You don't sense that the active phase or inactive phase is any stronger than the other in the immediate time frame. So again, this kind of neutral pattern, biased, weakly negative, but not enough to declare El Nino. And then finally, the CFS version 2 forecast, sea surface temperature forecast for the Nino 3.4 region, the official El Nino monitoring region. So temperatures were last year borderline, barely El Nino-ish, and then temperatures got cool over the summer, dipping slightly negative. Temperatures are rebounding. They're not as high as what this is saying. I think they're down 0.2 of a degree or something like that. So really about here. And the forecast has temperatures basically holding exactly like they are now the whole way through winter, maybe rising to 0.5 degree above normal as we get into May, and then settling down a little bit after that, but not dipping negative. This is good news. So again, we've talked about the PDO, the Pacific Decadal Oscillation, this long range. It's like a long term, like a 20-year El Nino, and when in the warm phase, when in the cool phase, it's like a 20-year La Nina. We've been in the cold phase of the PDO since December of 98, I believe it is, and the thought is in 2014, we pulled out of that, and we're weakly in the warm phase of the PDO. So we got another 15 plus years to go, which would be good. You can see it here. Temperatures biased slightly warm. If that were the case, that would be an indicator of that. Could also be an indicator of just warming oceans in general, but we're not going to go down that rabbit hole. So either way, though, we're not moving towards La Nina, at least not for this model. And so we'll just have to see. I mean, we got a ways to go. If we were going to fall into some steep La Nina pattern, it would happen probably in the February-March time frame, or certainly in the springtime pattern. And as of right now, none of the models are suggesting that. There's a bunch of other models we look at, but they're all saying basically the same as this. So this is a good representation of everything. So that's good news. Not great news, not saying El Nino, but certainly not saying La Nina either. So the short run of it is we have a gale north of Hawaii. It's generating some seas, going to push some swells south towards Hawaii, and then maybe a couple of dribbles towards the U.S. West Coast, but not much. Little tiny gale down south might create yet small swell for Hawaii, southern hemiswell, late season southern hemiswell for Hawaii, and maybe a little bit into southern California. But looking at the charts in the North Pacific, just nothing clearly indicating that we're ready to move into a pure fall pattern. And fall's almost here. You know, we're 6 weeks away from the start of winter, something like that. So we're a bit behind schedule. But we'll see where we end up. 6-7 weeks, I think it is, actually. Anyway, so not a whole lot going on. No indications of rain either or snow. So just kind of a lackadaisical pattern going on. The good news is we're not scheduled to move into La Nina at all. Just sort of this continuation through the winter. Supposedly a quote-unquote normal pattern for this time of year. But clearly we are below the normal mark. And we expect that to probably be the trend for the rest of the winter. All right, so that's it. If you enjoyed the video, hit the like button. If you have comments, questions, be sure to post them down below. We'll answer them. Yeah, it might take us a day or two, but we'll get there and we'll answer your questions. We're happy to do that. And then if you are not subscribing already, please subscribe, hit the bell next to that. You'll get notifications when we post updates, or you can just go to stormsurf.com. That's our website. Most of the data that you saw tonight is available there on the site. You can follow along every day and then get a wrap-up at the end of the week using this video. Thanks for watching. We appreciate you watching, and we'll do this again next week. Same time, same channel.